Here in this question, we have to find the number of minimal spanning trees by using Kruskal's algorithm. Here a graph is given, a weighted graph. For this weighted graph, we have to apply Kruskal's algorithm and find the number of minimal spanning trees. So for finding minimal spanning trees, we use two techniques, two algorithms. One is Kruskal's algorithm and the other is Prim's algorithm. Here we have to apply Kruskal's algorithm for the given graph and find the number of minimal spanning trees. So in Kruskal's algorithm, we include edges with least cost first. So let us write the nodes. First, write the nodes. Don't add the edges in the beginning. Now, after writing the nodes, let us add the edges by seeing the cost of the edges. In Kruskal's algorithm, we keep on adding edges with the minimum cost. So here the minimum cost edge is 1. So we'll be adding this one as the first edge. After 1, the next least cost edge is 2. So we'll add this 2. We should not add the edge if it is forming a cycle. Okay. Why? Because in minimal spanning tree, in a spanning tree, there will not be any loops. There will not be any cycles. So after 2, the next minimal cost edge is 3. This is 3. This is also 3. But we should not add this edge. Why? Because if we add this edge, we'll be getting cycle. So we should add this edge, but not this one. So after 3, the next minimal cost is 4. So we can add this 4 or this 4. We can add anything, either this edge or this edge, because adding of these two, either this edge or this edge, will not form a cycle. So let us add this edge in this. So this is one spanning tree, and the other spanning tree is for other spanning tree also. First cost one edge is added first, and this is not a spanning tree. We forgot to connect this vertex. So in order to connect this edge, the next after adding these edges, the next minimum cost edge is 5, but we should not add this 5. Why? Because here it is forming a cycle. So in order to connect this vertex, we should add this edge. We should not add this one. Why? Because it is of cost 7, it is of cost 6. So we'll be adding this. This is one spanning tree, one minimal spanning tree. Let us check if there are any other spanning trees. So after adding 1, we'll be adding the edge with cost 2. After 2, the next edge is 3 of cost. The next edge of cost 3. This we should add this one, but not this one. Why? Because it is forming a cycle. Now we can add either this edge or this edge. Both are of cost 4, but we should not add. We have already added this edge. This is the previous minimal spanning tree. Let us add this edge. If we add this edge, we are getting different minimal spanning tree. And the last edge is this one of cost 6. This is of cost 4. Here we should not add cost. Here it is cost 5, but we should not add this one. Why? Because it is forming a cycle. So these are the two possible minimal spanning trees if we apply Kruskal's algorithm. The number of spanning trees would be different, but the cost of each and every spanning tree should be same. Here the cost is 1 plus 2 3, 3 plus 3 6, 6 plus 4 10, 10 plus 6 16. Here 4 plus 5, 4 plus 1 5, 5 plus 7 10, 5 plus 2 7, 7 plus 3 10, and 10 plus 6 16. That means the number of spanning trees may be different, but the cost of each, all the spanning trees, all the minimal spanning trees is always same. And one more thing, the number of edges in the spanning tree should be n minus 1 if there are n edges. Here, if there are n vertices. Here the number of vertices is 1, 2, 3, 4, 5 and 6. So the number of edges should be n minus 1, 5. This is one edge, this is one other edge, 3 and 4, and this is 5. That means if there are here in this graph 6 vertices are there, and in the minimal spanning tree or spanning tree there should be only 5 edges. So here 5, we got 5 edges. Let us check in this spanning tree also. 1, 2, 3, 4 and 5. So here the number of minimal spanning trees by using Kruskal's algorithm is 2. So here correct option is option B.
Problem, we have to find the limit of integral y to a e power sine square t dt plus a to x plus y e power sine square t dt by x. Now, as the limit is from y to a and a to x plus y, I can write it as y to x plus y. So this can be written as limit extends to 0, integral over y to x plus y e power sine square t into dt by x. Now, in order to find the limit of this expression, what I do is I'll use L'Hospital's rule. L'Hospital's rule. So we'll differentiate numerator and denominator separately. Differentiation of a to b f of x dx is nothing but f of b into f dash of b minus f of a into f dash of a. So here b is nothing but x plus y, a is nothing but y. So if I substitute that value, it will be f of b is nothing but e power sine square of x plus y into differentiation of b. Differentiation of x plus y is 1 plus 0 minus differentiation f of a will be e power sine square y, and differentiation of y is nothing but 0 by differentiation of x is 1. So limit x is tending to 0. So I can write this as limit x tends to 0 e power sine square of x plus y. Now as x is tending to 0, this will be e power sine square y, which is nothing but option A.
A gentleman has 6 friends to invite. In how many ways he can send invitation cards to them if he has three servants to carry the cards? This gentleman has 6 friends. So these are 6 friends, and he has 3 servants. If he has to invite these 6 friends using 3 servants, the total number of possibilities would be, for this first friend he has 3 choices, for this second friend 3 choices, so on. For all the 6 friends he'll be having 3 chances. So the total number of ways of inviting his friends is 3 power 6, which is nothing but 729. So here correct option is, here options are first option 729, second option option B 18, C option C 646, option D none of these. So here correct option is option A 729.